Okay, characteristics of quadratic functions. I'm going to move quickly, so pause the video whenever you need to take notes. Okay, you should write these two things down in your notebook. A zero of a function is an x value that makes the function equal 0. A quadratic function may have 1, 2, or no zeros. I'm going to show you an example, a sketch of each of these possibilities. Okay, so here are the different types of zeros you can have. First, there's 1, 0. A zero is whenever the graph touches the x-axis. So this would have 1, 0, and the 0 would be right here. Next, we have 2 zeros, and that's when it crosses the x-axis twice. So the zeros would be here and here. And lastly is when there would be no zeros, and that's when it doesn't touch the x-axis at all. So you can tell how many zeros it has just by looking at the graph. All right, so here's an example. On this graph, there are 2 zeros, one here and one here. Well, when you are saying what the zeros are, you should list them like this. -1 and 3. And again, you're just seeing where they cross the x-axis. This one only has 1 0 right here because it touches the x-axis once. So the 0 is -4. And lastly, this one has no 0, so I'm just going to write none. All right. So axis of symmetry divides the parabola into 2 halves. So there are 2 different ways to find the axis of symmetry using the zeros or the graph. So if there's only 1 0, then the x-coordinate is the axis of symmetry. If there are 2 zeros, you have to use the average of the 2 zeros. Okay. So here are the 2 examples. Let me zoom in a little bit. Okay, here's the first example. So to find the axis of symmetry, when there's just 1 0, I'm going to highlight the 0 here. The axis of symmetry is just that number. So when I write it, I like to write A of S. Axis of symmetry equals 1 because the 0 was at 1. Next, we'll try this parabola. It has 2 zeros right here and right here. According to what we wrote down on the previous slide, we have to find the average of these two. So we have 0 and we have 5. To find the average, you add them together and divide by 2. 0 plus 5 is 5. 5 divided by 2 is 2.5. So the axis of symmetry is 2.5. If you were told to draw it, it should be a dotted line. And I know it's going to be 2.5. Oof, that's hard to see. 0.5. So I'm going to draw a dotted line here at 2.5 and back down. That's the axis of symmetry. You can see that both sides are equal, symmetrical, however you want to think of it. All right. Now we have a formula because sometimes the axis of symmetry is not going to show you the graph to find the axis of symmetry. So you're going to have to use this formula. Here is B and here's A. You don't use C for the axis of symmetry formula. This negative sign is often forgotten, so when I write the formula, I like to write the negative sign by the b. That way I'll use it in the beginning, and then I don't have to worry about it at the end. Let's start with an example. Okay, so we're going to find the axis of symmetry of this equation. So I'm going to find negative b over 2a. Okay, so let me identify a, b, and c here. A, B, and C are only numbers. So negative 3 is the A, 10 is the B, and 9 is the C. So for negative B, it would be negative 10 over 2 times negative 3. So we get negative 10 over 2 times negative 3, which is negative 6. You do have to simplify. We know a negative divided by a negative is a positive. 10 and 6 have 2 in common, so the answer is 5 over 3. Okay. Next, we need to write down these 3 steps. Okay, write down these 3 steps, please. This is how to find the vertex if we are given an equation. We already know how to do it with a graph because of lesson 9.1. All right. Example A is here to prove that it's best to just do whatever's easier at the moment. We have an equation and a graph. Here, it's very easy to find the vertex. Remember, the vertex is the top of the hill or the bottom of the ditch, so it would just be right here. So that's a lot easier than doing the 3 steps. So I would just write down the vertex, which is, again, the x and then the y coordinate. Here we have to actually do the 3 steps. First, I'm going to identify A, B, and C. Next, I'm going to write down, or we're going to find out what x is, and we do that by using the axis of symmetry formula. B is positive 6, so negative b would be negative 6 over 2 times negative 3. 2 times negative 3 is negative 6. Negative 6 divided by negative 6 is 1. So I know x is 1. The second step calls for me to plug this into the equation. So I plug this in to this equation, and every time I plug in 1 for x, I would put it in parentheses, just so my calculator knows what's up. All right, when you type in your calculator, you should get -4, or do it in your head, and that's for y. So our coordinate here would be 1, -4. Those are the 4 types of examples. We have one more. It's a word problem. Here we go. As I read the word problem, I want you to pick out some key phrases, and we'll go back and highlight them. The graph, and it gives you the equation, can be used to model the height in meters of an arch support for a bridge, where the x-axis represents the water level and x represents the distance in meters from where the arch support enters the water. Can a sailboat that is 14 meters tall pass under the bridge? First, we have to think about what are we even talking about. There's a bridge, and there's a sailboat. We also have this formula, which seems pretty important, and our big question. We have something that's 14 meters tall. Can it pass? So I'm going to draw a picture. It says it's an arch bridge, so let's draw an arch. We also have a sailboat. Let's see if I can get one instead of drawing it. Perfect. All right, here's my sailboat. Oop, that one definitely wouldn't fit. I'll leave some mystery behind it. We also know that the sailboat is 14 meters tall. So we need to find out if it would fit under the bridge. In order for that to happen, we need to know how tall the bridge is, so to see if it can pass under the tallest point. To do this, we're going to do the 3 steps from before. First, we are going to find the x coordinate of the vertex. So we're going to do x equals negative b, which is negative 0.6, over 2 times a, which is negative 0.06. Plug it into your calculator, press enter, and you should get 5. Remember that this 5 is for the x coordinate. So all it's telling us is it's 5 meters until it gets to the tallest point. But that does not mean the tallest point, I wrote feet, does not mean that the tallest point is 5 meters. It just means 5 meters from one edge of the bridge to the middle of the bridge. So next we need to find out the height. To do that, to find y, I'm going to plug in 5 into the equation. When I plug it into the equation, I get 11.76. And we know that y represents the rise. So we found out that the bridge, this color, is 11.76 meters tall, which means no, the sailboat cannot fit under the bridge. All right, there is homework. Double check RenWeb to see what it is. Have a great weekend.